There we go.
Welcome, and thank you for coming. Raise your hand if this is your first time at Build. Welcome, you picked a really good one to come to. Lots of exciting things being announced today. And for those of you that it's not your first time, welcome back. I'm Carmen from the Windows engineering team, and today I have with me Jeff Arnold, design lead from the Windows team. In this session, we're going to cover everything you need to know about building your universal Windows application. Thank you for your ongoing feedback and your participation in this conference, as well as with the Windows Insider program. The feedback that you've been giving to us, it's really helping, and it's directly influencing how we build Windows 10, and it's a bunch of stuff that we're going to cover in this talk today. What we've heard from you is that you wanted enhanced flexibility of the design and interaction model on Windows when you're building your apps. We'll talk about that today. For those of you who have historically built apps for Windows, as well as for Windows Phone, you asked for us to reduce the device-specific work. That's even more important now, as your applications will be running across even more devices. In addition, you asked, for those of you who have invested in other platforms, for the ability to reuse your designs and your code on Windows, and we're happy to say that you can do that as well. Please submit an evaluation form at the end of this session. In this session, we will be focused primarily on phones, tablets, laptops, and desktop PCs, and the design considerations that go along with those. However, that is not the extent of the reach of the Windows Universal Platform. Soon, these apps will be running on small IoT devices, HoloLens, the Xbox big screen in your living room, and even the Surface Hub. We're going to cover a lot of information here today, some of it high level and some of it more detailed, but know that you can find everything we talk about as well as much more information on the design.windows.com site. In a bit, Jeff is going to walk us through the design patterns for navigation, commanding, and content. But first, let's take a look at what exists in the platform that makes it easy to design one app that can adapt to many form factors. When we set out with a vision to create a system where an app could run on a vast array of device form factors, as well as input methods, we knew we needed to abstract as much of that from the app development process as possible. We want you to be able to focus on building your app and making it great. We thought hard about the most impactful things and differences across these various form factors, and we want to share that thinking with you today. First of all, window and screen size. Given that your application is going to be running on many form factors, a great app is one that will take advantage of the various screen sizes. As sizes increase, you can fit more content on the screen, and that is what your users will expect. We also had to consider supporting various input methods. Your users may be using mouse, keyboard, touch, pen, or even a game controller. So it's important to have a way to think about that and optimize for one-handed use in those cases. Also, it's important to know that your app, the user could be using your app in different ways across the different form factors. On a phone, a user may be using the app more for content consumption, whereas on a desktop PC, they may be using that same app for content creation. So knowing how to adapt your app across those form factors is important. That's a lot to consider, and we wanted to make it easy for you to take advantage of the thinking. So we've done a lot of the heavy lifting, and we're going to go through those pieces now. First of all, and you've heard this before, Microsoft has created an ecosystem of devices all running the same operating system. What this enables is that your application can target a wide range of devices. The platform easily allows you to adapt this one design across form factors, and of course, you can always tailor that experience should you decide to do so. To make this possible, we created a unified API set across Windows and Windows Phone to abstract many of the differences between these devices. We have also rationalized the common control sets between Windows and Windows Phone into one set of controls that are optimized to work on a range of sizes as well as input methods. You don't have to start at square one. You can use these building blocks that already exist and already have intelligence built in, such as scaling and reacting to these input methods. And when you use these controls, your app will look and work correctly without much effort on your part. Here is an example that shows the evolution and convergence of the app bar. So let's take a look back. In Windows 8.1, this is what the app bar looked like. It could be placed at the top or the bottom of the screen. It contained all the elements, both primary and secondary commands, in one place. The number of items was gated based on the width of the screen that it was running on, and we always showed the icon labels as well. This app bar was usually hidden by default, and that's just something to remember for a moment. Let's take a look back at the phone 8.1 app bar. This was a piece of UI that was always located at the bottom of the phone to optimize for one-handed usage. The maximum number of actions it could contain is 4, and then overflow actions were hidden behind a ... menu. When pressed, the app bar would slide up and the app menu items would show. To conserve space in the rest area, the icon labels were hidden by default as well. In Windows 10, we wanted to build a control that provided the flexibility of the Windows 8.1 app bar with the design considerations of the phone 8.1 app bar. What we've built for Windows 10 is a true hybrid of its predecessors. It can be placed in multiple positions on the screen, and the number of items that it contains is based on the width of the screen that it's running on. Let's look at this in a couple of examples. In this case, the app bar is placed at the bottom of the big screen. When the ... overflow is tapped, the app menu rises up into the space where you would expect it to be. We decided to keep this app menu just to a portion of the screen versus going across the whole screen because it just felt kind of clunky when it was across the whole screen. And you'll also notice we brought forward the Windows Phone model of having the icon labels hidden by default to conserve space and give more space for your application to run. In this case, this command bar is placed at the top of the screen. And the right thing just happens. When the ... overflow is clicked, the app menu comes down. And here, on the smallest size screen, we have optimized for one-handed usage by always keeping it at the bottom. When the ... is pressed, you see the app menu, and at this point, we let that app menu go full width so that your thumb can reach the menu just fine. All right, so we've talked about how the common controls scale across the form factors. Let's now move on to talking about input method. Some of the controls will react directly to how they were invoked. In this example for the context menu, what you see on the left is that this control was invoked via a mouse. And when that context menu opens, you'll see that the items listed are at a density level appropriate for mouse interaction, so the items are a little tighter. What you see on the right is that same context menu running on the same exact device, but when invoked via touch, same menu items appear, but they're much more spaced out. So this is all handled for you. Okay, here's another set of controls. Across the whole control set with Universal Windows apps, the controls include the appropriate affordances necessary for the different input methods. So the pivot control from Windows Phone continues to work the way that it did on Windows Phone. However, we're now bringing this to the desktop. And when we do, if your user is using a mouse, the appropriate affordances come up to allow the user to click through the various pivots. You also see these affordances showing up on the date picker, as well as all of the controls. So it's great that the common controls react to this input method, but what if you and your application have features, functionality, or commanding that you want to change based on the input method? Well, we have you covered there as well. There's a new API in the Universal Windows App Platform that enables you to listen to the dominant input method of a given device and then tailor your UI. Again, you're not required to do this. The common controls do it. You can choose to do it in your app if you would like. So far, we have covered the unified API set, as well as the converged common controls and the input methods. Let's keep going, though, because we're not done. We're introducing a concept called effective pixels. Effective pixels are pixel units which are independent of a given device. Simply put, effective pixels they allow your application to visually scale from screen to screen. And simply put, they allow you to design your application to a base resolution, and then our scaling algorithm takes over. It applies the viewing distance, the typical viewing distance of a given device, because we all know that you hold phones quite close to your face, but when you're looking at an Xbox screen, it's very far away. So our scaling algorithm will apply the appropriate viewing distance as well as pixel density, and then it optimizes the UI for perceived size rather than actual size. This can be a complex topic at first, so I have a video for you that we'll watch and see if it makes more sense.
Here we have a UI element that's 100 by 100 effective pixels, some 100-point text, and some 24-point text. Here's how these UI elements render on a PC, a tablet, and a phone. When the screens are compared side by side, elements on the PC and tablet seem larger than the elements on the phone. The 100 by 100 UI element displays in 100 by 100 physical pixels on the phone, 150 by 150 physical pixels on the tablet, and 200 by 200 pixels on the PC. These devices have different screen sizes, viewing distances, and pixel density, but when you take into account the viewing distance for each device, the elements all have the same perceived size. This enables you to use the same element sizes and type ramp for all devices. And that, in a nutshell, is how display scaling and effective pixels frees designers and developers from having to consider pixel density and viewing distance.
So we are really excited about this scaling algorithm. We think it takes a ton of the work abstracted from the app development process. We could talk a long time about effective pixels. We have a lot more content to get to, so I'd like to direct you to a theater presentation that's happening just down the hallway. It's happening 3 times, today, tomorrow, and Friday. And Eugene, one of our design integration leads from Microsoft, is going to be going through the details on what effective pixels are and why you should care. So while effective pixels allow you to scale your app visually from screen to screen, something else that you can use effective pixels for are breakpoints. Breakpoints are screen widths in effective pixels where there's opportunities for new layouts. For instance, 320 effective pixels is the smallest screen that Windows Phone will ship on. We built the common controls for this size and up, and generally when your app is in this mode and is running at 320 effective pixels, either a phone or a small window on the desktop, it supports one pane of content, like a message list from email. A width of 720 effective pixels is a common point where apps will want to move to 2 panes of content, if that makes sense for your application. This will be prominent on Windows tablets, as well as a 5.5-inch phablet device turned into the landscape orientation. And we know that our users expect much more functionality as those pixel sizes increase. And lastly, there's another breakpoint at 1024 effective pixels. This is a breakpoint where it could make sense to move to a 3-pane layout if it makes sense for your application. To see what this looks like in practice, here's an example of the Mail app running at these 3 different breakpoints. In the smallest window, you see 1 pane of content, which is just the message list. As the screen gets larger and we move up to 720 effective pixels, we move to a 2-pane layout, both the message list as well as a preview pane. And then third, when we get to 1024 effective pixels, we now have the account and folder list, the message list, and the preview pane. This is a really good example of taking advantage of those breakpoints. The reality is you get to decide if you listen to these breakpoints and then what your app does at these various breakpoints. So as you've seen here, there's already a really strong foundation laid to enable you to design your app to run across form factors. Let's move forward and learn how to design your application using the Universal Windows App Patterns. To walk us through these, please welcome Jeff Arnold, Design Lead from Windows.
Okay, so now that we've seen a number of the things that the system and the platform are going to do on behalf of you to help you in developing your app, we're going to take a look at some things that design-wise you should take into consideration. Every application is going to be made up of 3 discrete elements. First is the content. Microsoft has led with the mantra of content over Chrome for the last number of releases, and it's no different now. This is the bread and butter of all of your applications, and so you really want your content to stand out more than anything else. Second is commanding, or a way of taking action on the content. And third is a way to navigate to different sections of the content. So when choosing your navigational pattern, there are some considerations to take into account. First is priority of navigation. Just because your application may be broad and deep doesn't mean that necessarily that your user's constantly changing to different sections of your app, therefore it's okay sometimes if, let's say, like the navigation is out of reach of one-handed use. Take the size of device into account. Again, on a smaller device, one-handed use is often very important, but then on larger size devices, you have plenty of room to fit in as much content as possible and expose high-level navigation and really make the app as usable as possible. To optimize for content layout, the navigational pattern that you choose can inject a hierarchy on the page, on the content of your page. So you should choose a navigational pattern that is appropriate and is pleasing to and works along with the content that's on the page. And the last is primary input method. Some of the navigational patterns that we have work better for mouse and keyboard, and others are just more delightful when used with touch. So I want to start, before I get into the navigational patterns that we have, I want to say that there's no single required pattern as part of Windows 10. We want you to go out and we want you to innovate as much as possible on Windows. What we have done is we went out and we did an audit of all the conventional patterns that are out in the world today, regardless of the platform that they're implemented on. We made sure that there's a way that you can bring your apps to Windows and use them. The patterns we're going to talk about here are pivots, tabs, hub, master detail, and the hamburger pattern. So pivots is probably the most iconic controls that we had on Windows Phone, so of course they're available here on the new platform. For folks that don't know how pivots work, there's a string of headers that go across the top of the page. In order to change from section to section, the user just simply swipes on the body content and the content is swapped out. If I apply the considerations that I talked about earlier to pivots, it works something like this. Pivots allow for frequent access to exposed navigation. They're always at the top of the page. The user can see them and always access them. Because of the way pivots work, it works well on both large and small screens, but because of the flicking left and right navigation, it works really well for one-handed use as you look at your phone devices. As far as optimizing for content layout, the pivot header works really well to set up the hierarchy of your page. So it's just the user knows when they come to the page that this is the top and then everything just reads down. Long string lengths with the pivot control are okay because as the string lengths become longer, the pivot just bleeds off to the right, and as you swipe them in, then you can see the complete titles. Because of the nature of this horizontal navigation, you want to avoid using controls inside of the pivot control that also have their own horizontal navigation. This kind of leaves the user with an inconsistent experience inside of their app. Now, the pivots work well with pretty much all input methods, but they're most delightful when used with touch. That's why we created them in Windows Phone to begin with. Over the years, we've found through user research that it's really better to have no more than 6 pivots at a time, because for any number of pivots above 6, the user becomes disoriented and they start losing track of where they are inside of your app. As we began to evaluate pivots on the larger screen, we started to see a little bit too much motion with the carouseling behavior of the pivot header itself plus the body content. So what we decided to do was add something new. At the point that all of your pivot headers fit on a given page, the pivot header now locks in place, and now the pivot will take on a more tab-like functionality. And consequently, this also is more appropriate for these larger screens where the mouse will be used. This also brings us to our second pattern, which is tabs. We recommend that you actually build your tab UI using our pivot control. You simply restyle the headers that are inside of the pivot, and the control will take care of everything else for you. It is also recommended that you have no more than 5 tabs on the screen at a time. This is the largest number of tabs that will fit on the smallest screen that Windows Phone will ship on and still reach the minimum hit target for those tabs. So the considerations for tabs is very similar to pivots, with a couple slight differences. Tabs are very good for instances where muscle memory is important. So let's say I have a dialer app and my user knows that the voicemail tab is the second tab. They can always come there, they can always just tap on number 2, and it's always in the exact same place, regardless of the layout. As far as size of the device, the tabs work really well on large and small screens, but typically have a larger footprint than pivots. So that's just something to keep in mind. Because of the traditional layout of tabs, typically an icon over a string of text, typically is higher than just the string-only visualization on pivots, and it pushes the content down. So just keep in mind what the visualization of your tabs do to the layout. Like pivots, the tabs set up a clear page hierarchy, and it does work well for all input methods. So the next pattern is hub. I'll go through the considerations for this, but if you want to see a more deeper dive into a practical application of the hub across all the devices, you'll want to attend Lynette's talk on Friday at 2. So the hub was another pattern that we had on Windows Phone, and it allows you to access a lot of content all at once. Typically, the way this worked is there's a number of sections across the pane. Each of those sections contain a preview of the content that lived inside of that pane, allowing the user to see what the section kind of held before they really had to deep dive in to get to all of the content. It maximizes the use of the real estate very well, and works very well for one-handed use because it's just like pivots, it uses the same flicking gesture. Keep in mind that the hub is not really the best used for a consumption, it is best used for a consumption app. Typically, the user kind of browses through the content like a storefront. It's not well utilized if you have an app that you just want to get stuff done, or the user just wants to get to their content. Typically, the hub will inject an extra level of hierarchy that just kind of gets in the way of what the user actually wants to get to. As far as primary input methods, the hub works very well with touch, and it works very well with game controller. The next pattern will be pretty much familiar to anybody that's ever had an email client. It's master detail. The way master detail works is there's typically a list view on the larger screen on the left-hand side with a bunch of items. As soon as you tap on one of those items, the right-hand side, which is the detail pane, is updated to show that content. As this pattern shows up on the smaller screen, these two layers end up getting stacked on top of each other. So when you tap on an item on the list, you're actually drilled down to the content layer, and then you have to utilize the back button to go back up. For consideration here, the master detail navigational pattern is a way of navigating the content that is already on the page. You could actually nest this inside of one of the other navigational patterns. You don't necessarily need to, but this one works well for that. Because of the way it takes advantage of the screen real estate being side by side on the large screen and having the drill behavior on the small screen, it takes advantage of the screen real estate very well. And it works very well with all input methods as well. So the last pattern I'm going to talk about here is the hamburger pattern. This pattern was specifically brought to Windows because we want you to be able to port your apps directly from other platforms, and it's actually been one of the most asked for patterns over the last couple releases of Windows. As we look at the considerations for hamburger, you'll see that the hamburger is really kind of a double-edged sword. On large screens, it works well because by default, the navigational pane can be expanded by default, leaving all the navigational elements exposed. And what the user can see, they can obviously find. However, as the screen size is reduced, typically what happens is the hamburger or the pattern is reduced down to just the hamburger, which, as we know, it decreases engagement inside of your app. This may be okay as long as the user needs to access that navigation infrequently. And also because of the conventional position of the hamburger up in the top left-hand corner, it doesn't work very well for one-handed use, but again, that may be okay as long as access to this navigation is infrequent. And it works well pretty much other than one-handed, it works well for all input methods. If I take a step back and take a look at this MSN app, let's say this is actually a good example of how to use the hamburger pattern. As you can see on the right-hand side, when on a larger screen, the pane is expanded by default, giving access to these higher-level navigational elements. But the content that the user really has access to is all in that right-hand pane with the pivots where all the content actually lives. As you look at the smaller screen, the pattern is reduced down to the hamburger. And it's okay because you typically don't need to access that hamburger. All of the content is still built into the on-page pivots that are already right there on the user's finger. As another example, I wanted to show the new Outlook on mobile app. Again, I'd say this is a good use of the hamburger in this instance. As you can, behind the hamburger is the folder view for this given mail application. Our typical users get between 10 to 20 emails a day, and they live inside their inbox. They don't need to do a bunch of switching of folders. So it's okay that hamburger is up in the left-hand corner and out of use. What's important is that the content and the actions that you can take on the content are down at the bottom of the screen and underneath the user's finger. So when we decided to bring the hamburger pattern to Windows, we decided we wanted to try a few things to see if we can make it unique to Windows. So the first thing that we did is we wanted to test a couple different glyphs. The first one we came up with was called the home burger. It was just something unique, it was just different. And we wanted to see if we could change the hamburger into something else that people would say like, oh, that's the Windows way of doing it. The second was to use the app icon. We figured this would be a way of killing two birds with one stone. Like the app could brand itself and the user would know that they could go up there to navigate the app. And then of course we had to test the hamburger. So the way we do testing is we test against personas. So a persona is a representational user that has criteria that basically fits a set of our user base. And for this testing, we tested with Hope and John. Hope is an 18-year-old college student. Because of her age, she had probably her first real device that she had was a smartphone, and it probably had a touch screen. And given this is probably why her test actually turned out very, very well. No matter what icon we put in front of her, she knew exactly what to do. She's used to the touch paradigms and just assumes that anything in a touch universe is touchable. Then we go and we look at John. John's a 40-year-old guy, and he actually has way more of a backstory than you would think you would need to test software. The researchers got really into this guy, but the pertinent information about him is he's 40 years old. He's probably lived through every interaction paradigm that Microsoft has ever come up with, and he's very, very accustomed to using the mouse and keyboard. So when we put the icons in front of him, it was a completely different story. With the home burger and with the app icon, he failed at most of the tests that we put in front of him. However, when we tested with the hamburger, we were actually kind of surprised. He didn't succeed at every single task that we put in front of him, but he was able to accomplish most of the tasks that we had put in front of him. So because of this, we decided to stick with the traditional, conventional hamburger icon. The second thing we wanted to test was the location of the hamburger. As you know, in most applications, it lives at the top left-hand corner of the screen. We wanted to try and take a look at some of the problems that we're having on mobile, where it doesn't work very well for one-handed use, and so we wanted to see if we could move it to some other place on the screen where the user could get to it easier. Pretty much the results came back pretty similar as the icon results. What ended up happening was any other position of the hamburger reduced engagement in the app, and it actually didn't work out that well. So with the new split view pane, which is the control you'll use to implement the hamburger pattern, we recommend that it's in the top left-hand corner and uses the conventional three-stripe hamburger icon. So the next thing I'll talk about is commanding. Right now in Windows 10, there's two different ways to take action on your content. There's a context menu and the command bar. The context menu is a common control that can be applied to any UI element that you would want to take action on. And it could be invoked by either right-click with the mouse or press and hold for touch. because of the hidden nature of this entry point, we would recommend that you probably not put any actions inside of the context menu. That's not surfaced somewhere else in the app. We don't want to leave a user with a dead end where they don't know where to perform a very specific task. The second control that we have in place now is the command bar. Carmen kind of talked about this one a little bit earlier. The new command bar can be placed at the top or bottom of the screen. We recommend that you place it at the bottom of the screen on mobile devices for one-handed use. In Windows 8, there was one app bar, and it was placed across the bottom of the screen, and it spanned all the panes inside of that app. And it was sometimes confusing when you had an item selected if the commands that you were taking action on were adhered to that item or an item in a different pane. Because of this, we're suggesting that you can actually add our command bar to multiple panes inside of your app. So as you can see here, it's very clear which actions are associated with the list view and which actions are associated with the details pane. The command bar still is limited to the amount of the actions that can fit on the screen for screen real estate. Although we still recommend that you probably have no more than 4 primary actions. Like I really kind of doubt that you have too many apps that have 12 primary things you can do on a specific object on your app. Like usually your app, you want to focus it in on the one thing that app is there and really good about. And so those secondary and tertiary actions can be hidden underneath the ... flyout menu. So the last thing I'll talk about here is content. I would argue that the way that you can reflow content in Windows 10 is no different than what you've already been doing on your websites and actually for your scaling of windowed apps on Windows up to this point. In order to talk about the techniques here, we've kind of deemed them as the 6 R's. These are resize, reflow, reposition, reveal, re-architect, and replace. Now, I'll go through some design considerations for this. However, if you want to see how to implement these inside of XAML, you want to attend Tim and Harini's talk tomorrow at 2 p.m. So the first technique I'll talk about is resize. This one's very simple. Pretty much any simple text editor will do this as long as you have word wrap turned on. So it is just a single column of content that is scaled appropriately to the size of the device or the window that it lives in. As the size of the device or the window is reduced, the content just rewraps inside of it. The second technique is reflow. This one's not too different from the previous one, except what started as 2 columns of content in the first pattern gets reduced down to a single column as a screen size is reduced. The third technique will be reposition. We all know that your app can be made up of multiple sections of content that are just laid out throughout the screen. With reposition, we have section A and section B. When the screen size first starts to be reduced, section A reduces in width. However, once you reach a snap point, let's say under 720 effective pixels, and you don't have enough room to fit the content side by side, the content then snaps to a new layout where it becomes vertically scrollable. In a more real example, this is a app detail page from our store. You can see how the items get reflowed from the desktop screen to the mobile screen, and you prioritize the content as it flows down on the mobile device. The next technique is reveal. Now, this isn't necessarily a way of handling your content, but making sure you're doing the appropriate thing for your app. So this is a food truck finder app. So if I'm at work or I'm at home on my tablet, there's certain things that I might want to do with this app. Like I would want access to all the food trucks that are in my area, see some popular trucks, maybe I've favorited some things, or see a schedule of the things that are going to be around me. And so I'm going to really kind of plan where I want to go. However, if you look over to the left-hand side, you see on the mobile app, we've replaced the favorites with a check. You're doing the right thing here by swapping out between favorites and check-in, because when you're at that food truck, you can tap on the check-in tab, fill out the appropriate information, and check in and let people know where you've been, what you've eaten, and give a rating, send a rating to all your friends out there. This is doing the right thing for your device. This is tailoring your app to make sure that it's taking advantage of the like the sensors and all the technology that's inside of the different devices. So the fifth technique here is re-architect. This is what's used by the master detail pattern that I talked about earlier. As I said before, on the larger device, the master detail fits side by side with the list view and the detail pane. However, as the screen size is reduced, only the list view is visible, and then you have to drill in and then navigate via the back button. And as you can see here, this is how it works within our People app. So the last technique I'll talk about here is replace. Device context, within the device context, you may want to have a different type of navigation that is more suitable to the device that you're on. As you can see here in our Photos app, we take advantage of the hamburger pattern on the larger screen. What this does is it leaves a lot of extra space for the beautiful content on the right-hand side with a smaller footprint of the hamburger on the left. As screen size is reduced and you look at the phone side, we have said that it is more important that all of these sections be accessible via one hand, and therefore they're using pivots in this instance. This is just another way that you can take advantage of the real estate and do what's appropriate for the device. You can choose to use the hamburger, you can choose to use pivots across the full range. However, you may want to just make decisions around like what is the best context of that device so that you're putting the appropriate navigational pattern on each of the devices. So what we've seen in this session is what the system and the platform are doing to help you in developing your app. And we've also talked about how to handle navigation, commanding, and content. So what we're going to do for the remainder of the session, we're going to open up for some Q&A. And then be sure to visit the Design Theater for some of our design sessions. So if you'd like, you can stand please walk up to the microphones inside of the aisles.
Are transitions part of the vocabulary for the HIG, and transitioning on a screen when you go from large to small between some of these states? Are you talking about some of those in the context of transitioning on one device between sizes?
Yes, that is handled on the HIG site, which went live today.
Okay, thank you.
Hi. I noticed that the new Start menu has some 3D transitions for the live tiles. Mm-hmm. And I was wondering if the 2D paradigm of Windows 8 is kind of getting supplemented with some 3D love.
So yes, we're looking at some new interesting effects and just ways of augmenting what was the old system so that we can evolve it. And we're trying out just new paradigms to see like what works well in this new system.
That's great. Thank you.
Any other questions?
Oh,
Okay.
he's working his way over.
What about like resources, right? Images, scaling those? They don't. If you have a small image, you want to have different sizes for each platform, basically.
Yes, so the question is, from an asset perspective in images, do you have to provide images for every single device? The answer there is that we have different scaling plateaus in the system that are all very well documented. And the reality is if you provide a very high resolution image, we will just go ahead and use that to downscale to the other devices and it will look fine. There are certain situations, and there's a talk tomorrow on the new continuum for phone. If you saw in the keynote today, so you'll be able to power a desktop monitor with your phone. And if you only included really small assets on the phone, you would want to consider in that case specifically including higher asset images because it will be displayed on a big screen. But for the most part, it's handled by the system, given what you provide. Yes?
So you talked about the command bar. With the app bar previously, you would swipe down from the top. So is there a recommended way now to have command bars come and go?
I can, so with that one, we're actually recommending that they're on the screen by default. So with Windows 8, the recommendation was that they were hidden by default, and that was really to give more visibility to the content that was on the screen. What we found was there was some usability issues with that. People weren't always sure how to find the hidden gesture. I mean, everyone's nodding their heads, yes. So we heard you, we listened, and now with Windows 10, those command bars are on the screen. And in fact, I mean, best practices-wise, like just always put stuff on the screen that you need your users to interact with. Yes.
With the master detail setup where you recommended when you go down to a phone, you switch to drilling down to the details. Is there a mechanism, have you built something to make that easy to do? Or is that something that would have to be manually implemented?
So I feel like that might be a good question. If you attend Tim and Harini's talk tomorrow, they would have some actually, if you go to the expert lounge as well, there's some folks there that would have some good recommendations on how to achieve that. We're designers.
Yes.
Just going back to the previous question about the different sizes for the assets. So does that mean that the graphics designer has to provide different sizes for, say, when designing an icon? You must have 3 different sizes for the icon to the size of the screen, right?
Oh, not necessarily. So it's more about the resolution.
Question.
Oh, sorry. Yes, repeat the question. The question was when you're providing icons for the applications, how many of those icons in different sizes do you need to provide? Again, the visual scaling happens within the system itself. However, there are certain cases where you'll, if you're writing, and targeting the phone specifically, know that the phone will be able to project to a big screen. And so think about the assets that you provide. It's really up to you whether you provide one set at high resolution images or whether you provide multiple sets to be optimized.
So if I provide multiple sets, the system will actually pick up the one that's most suitable for the screen size, right?
The question is, if you provide multiple asset sizes, does the system handle showing the appropriate ones? And the answer is yes. Can you please make your way to the microphone, if you can? Thank you.
It's for the webcast.
Yeah.
So is there improved support for vector graphics, like SVG or something like that, to avoid the different assets problem?
Oh. I do not believe at this moment. Again, I think that's more of a technical question that you could bring up to one of the folks in the expert zone. But SVG is one of those ones that I think that we have been considering for quite a while, and it's just one of those things in the backlog that we just haven't got to yet. It's well known that that's one that people want.
I am sorry to bring up images again, but if I think about the assets and if I think about, say there's an app and I have a background image, say I have 5 background images, and if I have to provide HD resolution for all of them, very high resolution, say 1320 by, I don't know, 768, I don't know what it is. I'm afraid that the app size would actually increase to a very large one, and then, that could be a problem because users may not download the app itself. Is there a thought process behind what you would recommend?
Yeah, I think there sounds like there's a whole bunch of questions about that, and I think what we'll do is we'll head to the Windows Insider Lounge tomorrow. We'll make sure between now and then that we get a good answer for that. Definitely hearing folks that sounds like a concern.
Hi, just wanted to follow up on all these imaging questions. There's actually a pre-recorded build talk from Steve Wright, who talks about this in great depth.
Perfect.
Talks about if you only want to provide one asset, what asset should you provide? If you want to provide 2, which 2 should you pick, etc. And he also talks about things like asset packs. So in your particular case, if you had 5 different versions of the same asset, Windows will download the most appropriate one for the device the customer is on. So they won't waste a lot of disk space, a lot of bandwidth, downloading assets that they can't use. So look online on the pre-recorded talk from Steve Wright, W-R-I-G-H-T, on scaling.
Thank you.
Thank you, Peter Tor. Any more questions?
How does the effective pixel work on WinJS or HTML, CSS apps? Sorry, I can't.
How does it work for, I'm sorry, the question is how does it work for WinJS and?
Yeah, so JavaScript,
So that one actually is a question that came up earlier, and I need to follow up on that. We have been working with the WinJS team same as we've been working with the XAML team this release. I am like 99% certain that it will be handled the exact same way, but I have to go back and check to make sure that is true. And you should actually go talk to Eugene Gavrilov out here. He's one of our design integrators, and he's going through the effective pixels. I believe he has a session tonight at 7 in the theater where you can ask questions like that, and he would probably be the best person to have answers for that.
Oh, you have one more? Sure.
Photoshop. We are working on, right now we have Illustrator, and I think we're working on the Photoshop layouts that will be uploaded to the dev.windows.com website.
All right, there are pretty obviously some business applications that are sufficiently complex that none of the patterns that you have shown would encompass what the interactions you would need to do.
Sure.
What's your thinking on trying to find where that line lies, where you start stepping outside these established patterns and start to design a custom pattern for a specific app because of its complexity or other considerations?
I mean, like, I don't think that the app has to get all that complex for you to try and evolve and just do something different. Like I said, like the patterns that we have here that we presented today are those conventional patterns that are already out there, so we want to put those out as a starting point for you. You know, as you get into things like LOB and those type of applications, the thing that also to remember is like Windows 10 we kind of level set. We started with what we had was like we had the Windows Phone controls and we had the Windows controls. We had to combine those into a single set. So now we have a baseline and we're going to start building back up from there. So a lot of these controls that you use for like an LOB app are these more complex apps. As we see folks trying to do new things with those, then we'll start to provide new tools to help you along the way for that. But I don't even think it has to do with the complexity of an app to say like I just want to do something different.
Just to hit on that for just another moment to make the point, you know, we're pretty prescriptive in Windows 8 about the guidelines and what we wanted, the kind of more of the do's and don'ts. And with Windows 10, what we're saying is you guys know your customers best, you know your app's requirements the best, and so bring your code to Windows and do what you need to do. And there's a ton available on the platform for you to do that, but where you need to come up with something new or a new pattern, totally appropriate to do that.
And also, like, I think you've heard it all day. I want to reiterate, though, like, we want all the feedback around the controls that we have today and how you are actually using them and where they're falling short. So, like, as my team kind of develops for, like, the next kind of drop of the common controls, we want to be able to make sure that we're doing the right thing so that when you drag that control onto your page template the next time, it actually provides you the experience that you are looking for to begin with. And we want to be able to like allow you to tailor with these controls to the way you see fit as well.
Okay, great. Well, we'll be up here for a couple minutes if you want to come up and ask a question. We'll also be in the Windows Insider Lounge tomorrow at 11:30. Thank you so much.
Thank you.